Today, we're diving into a brand new theory that gives us a fascinating, new way of looking at one of the most fundamental processes in the universe, how things fix themselves.
So, let's start with a puzzle. You've seen it a million times. A flock of birds gets scattered, and then, almost like magic, it reforms. A computer network hits a snag, and the traffic just reroutes itself. How on earth do these complex systems just put themselves back together after they've been disturbed?
You know, we always see the before picture, where everything's a mess, and then we see the after picture, where it's all back to normal. But that part in the middle, the actual healing process, how order spreads through all that chaos, well, that's kind of been a black box. We've been missing the how.
Well, a new theory called the Coherence Continuity Principle has this really wild answer. It suggests that order isn't just some static quality a system has. No, it's something that physically moves, something you can literally watch travel through a system. Okay, let's get into it.
So to really get why this new idea is such a big deal, let's first take a quick look at the old way scientists have usually thought about this problem. The traditional method is kind of like taking snapshots, right? We can measure how orderly a system is at one moment and then measure it again later to see if it got better. But that's like seeing a photo from the start of a race and one from the finish line. You know who won, but you have no clue what happened during the race itself. You're missing the whole story.
And this is where the Coherence Continuity Principle, or CCP, which is way easier to say, comes in. It hands us a completely new lens. It asks us to stop thinking of order as a static score and start thinking of it as something that can actually flow, kind of like heat or water.
Okay, first up, we've got to define a key term here, coherence. For our purposes, just think of it as a number. It's a number that tells you how orderly, how in sync a specific little spot in a system is. High coherence means lots of order. Low coherence means it's a total mess. Simple.
And this brings us to the really mind-bending part, coherence flux. The theory says that order, that coherence we just talked about, can physically move from one point to another. It's like heat spreading up a metal spoon in your coffee. Yeah, you heard that right. Order can literally flow.
The core idea actually boils down to a pretty simple budget. The change in order at any one spot is just a combination of what's happening locally. Is order being created? That's a source, or destroyed, a sink. And then you factor in what's flowing in or out from its neighbors. That's it. It's basically a conservation law, but for order itself. Pretty cool, huh?
Okay, so this whole idea of order that flows, well, it leads directly to the theory's biggest, most exciting prediction.
According to this theory, a system can heal in one of two ways. If it's passive, order just kind of slowly bleeds into the messy parts. It's like dropping ink into water. It just slowly, lazily spreads out. Super inefficient. But if the system uses active feedback, the theory predicts something way more dramatic. A repair wave. A sharp, clear, moving wave of reorganization.
And here's the kicker. This is not just some nice-sounding metaphor. This is a real, testable scientific prediction. You can prove it right or wrong. If the theory is right, we should be able to actually see these waves of repair and even measure how fast they're going. It's the smoking gun for the whole theory.
And that leads to a crystal clear test. With those passive, slow bleed systems, recovery time gets bogged down really fast. If you make the damaged area twice as big, it takes 4 times as long to fix. But with the system that has active repair waves, it's totally different. You double the size, it only takes twice as long. It just scales up. That is a massive night and day difference that you can actually measure.
Okay, this all sounds awesome in theory, right? But how in the world would you actually see one of these repair waves in action? Well, the source material suggests some beautifully simple and pretty clever experiments to do just that.
You can actually test these predictions in a bunch of different domains, from straightforward tabletop physics to computer simulations and even simple electronic circuits.
Let's just focus on the most intuitive one, the one you can almost picture in your head, the metronome array. I mean, you could literally build this on your kitchen table. You just put a few ticking metronomes on something that can move, like a board on top of 2 soda cans. Eventually, they all sync up. Then, you mess one of them up, and you can literally pull out your phone and film the wave of re-synchronization as it travels from one metronome to the next.
So, what's the big picture here? Why does any of this matter beyond some ticking metronomes on a board?
This quote from the paper just nails the huge shift in perspective here. We stop asking the static question, how orderly am I right now? And instead we start asking the dynamic question, how is order moving through me?
So what the Coherence Continuity Principle really does is give us a whole new language, a whole new toolkit. It's a way to talk about self-repair using the language of physics. It makes a clear prediction we can go out and test, and it finally connects our gut feeling about healing to actual math. And get this, the theory even hints at a new way to think about something like awareness, framing it as how sensitive a system is to this flow of order. Wild stuff.
And that, really, is what I want you to take away from all this. This isn't just some abstract theory for scientists. It's a new lens for you to look at the world with. It's a new pattern to spot. From an ecosystem recovering from a fire to a market correcting itself after a crash, the next time you see a system pulling itself back together, ask yourself, wait a minute, could I be watching a repair wave?